All right, so the first part of this one is asking us to calculate the acceleration between 7 and 9 seconds. All right, so we calculate acceleration by going VF minus VI over t, unless we can calculate slope using y equals mx plus b. We can't do that because this isn't one single linear graph, okay? So we're gonna use this formula instead. All right, so at time 9 seconds, the velocity is 0. Okay, at time 7 seconds, our initial velocity is 3. And that takes 2 seconds because it's between 7 and 9 seconds. So we're looking at negative 1.5 meters per second squared. All right, just plugging numbers into the formula. Everybody okay with that? All right, next one is total displacement between 0 and 7 seconds. So it's a velocity versus time graph, which means we got to use average velocity times time slash the areas underneath the line. So here's where 7 seconds is. So I'm going to start drawing my shapes. So that's probably the least number of shapes to have to calculate the areas of. Okay. So I got this small triangle here that's 1 by 1, so its area is 0.5. Okay. Then I've got this rectangle here that's 1, 2, 3 on the base by 1, so it's 3 meters. Okay, I've got this triangle here that's 2 high by 2 long, so 2 times 2 is 4, over 2 is 2 meters. And then I've got this final rectangle that's 1, 2, 3 along the base and 3 high, so it has an area of 9. Okay, and now what do I do with those numbers? I just add them up, right? They're all positive, so I don't have to worry about it. Okay, so we're going to have 14.5 meters, and that's positive. Okay, as our total displacement to 7 seconds. Okay, part C wants to know the average speed over the whole trip. If I want to find average speed, I need total distance and total time. Okay, well, the total time is easy. Okay, it's 9 seconds. Okay, I need the total distance. So I've got one more triangle I've got to calculate the area of, so that I can have that last distance here. So it's 2 on the base by 3, so 2 times 3 is 6, divided by 2 is 3 meters. So we'll add that to the 14.5. That'll be 17.5 meters divided by 9 seconds, okay? And that should give us our 1.94 meters per second. Okay, no direction on that, no positive on it, because speed is scalar. Okay. And then lastly, it wants to know the acceleration between 2 and 4 seconds. So at time 4 seconds, I'm moving at 3 meters per second. So again, we got A equals VF minus VI over T. So that'll be 3 minus 1 divided by 2 seconds. Okay, so we're looking at 1 meter per second squared, okay, as our acceleration during that time. Okay. Questions on that one? That would be a very typical, like, exam type question. Okay. I would ask you to do those exact same things, most likely on a test. Probably not as many shapes as that. It might be a shorter graph, but those are the things I would definitely ask you to do. Okay, we're not going to bother with this one, but remember we did talk about how you draw those tangent lines if you're being asked to calculate instantaneous velocity. Okay, I'm not going to ask you to do that for a couple of reasons. First off, it's no longer part of what we have to do, and secondly, there's such a wide range of answers that I'll get that are reasonable that it's hard to make a cutoff for, okay, this person drew a tangent line, but they didn't draw it right, and so their slope is too far off, so I can't give them a mark even though they knew what to do, okay? Because really, if I'm trying to find the instantaneous velocity at 4 seconds, everybody draws that line a little bit different, okay? And so everybody's going to get a slightly different answer, and it's really hard to kind of make a cutoff point, okay? I end up just giving everybody their marks for method as long as they did it right, okay? So it kind of takes away from the question a bit. Okay, I would like you guys to try this one. This is back to position versus time. I know it's not very clear, so I'm going to rewrite the numbers here. This is 250, this is 500, this is 750, okay? And it is in meters. Okay, and then this is time in seconds. All right, so we got 100, 200, 300, 400, and 500. Okay, so this is in seconds down below because I know it's hard to read. Okay, so I want you guys to calculate the things that you're asked for there. Okay, remember that this has now gone back to a position versus time graph. Okay, we've got to be able to switch gears. Okay, because I could give you a question on a position time graph and then switch over to a velocity time graph. Okay, so the big thing is that we got to switch gears to thinking about how position versus time graphs work. Okay, so part A wants me to find the average speed over the whole trip. Now, recommendation here, because I'm not seeing a lot of these out right now, okay, but I would suggest that you have your periodic table out, because on the back of it is the formula sheet. And sometimes looking at the formulas helps to trigger you as to, oh, right, that's what I got to do on this question. Okay, so as we get further and further into this unit, you're going to need that formula sheet out, because there's a lot of formulas on there that we're going to use. Okay, so it'd be a good idea to kind of get familiar with it. Okay, so for average speed on your formula sheet, it looks like this. It says delta D over delta T. Okay, delta means change. Anytime you see delta, they're actually meaning do this, final minus initial, even with the time. I mean, technically, when we write the time, it is actually the final time minus the initial time. Okay, everybody with me on that? We just usually abbreviate it as just T, elapsed time. So for the distance, okay, I can't actually do final position minus initial position because that doesn't calculate distance, that calculates displacement. All right, so what I'm going to do instead is figure out how far each one of these sections is and then add them all together to get the total distance. All right, so in part A, I go 500 meters because I go from 0 to 500. Okay, and then in part B, I go from 500 to 750, so that's 250. I could have also just written that this whole part was 750. Everyone okay with that? How far do I go in part C? Nowhere, right? I stay at that position, and then I go back 750 meters again. So my total distance is 1,500 meters. Okay, 750 plus 750. Everyone all right with that? Okay, and then the total time is 500 seconds. All right, so if I go 1,500 divided by 500, I get a speed of 3 meters per second. Questions on part A? All right, part B wants to know the average velocity between 300 and 500 seconds. Okay, so velocity is the total displacement divided by the total time. All right, that means final position minus initial position over final time minus initial time. And this is what tripped people up on this question. A lot of people wrote 500 seconds for the time. That's the final time. What was the initial time for this question? 300. It wants to know the average velocity between 300 and 500 seconds. So I go 500 minus 300 on the bottom, get my 200, okay? And then I go 0 minus 750, okay, on the top for my positions. Okay, everyone follow on that? So what I end up with is 750 divided by 200, okay, and that's going to give me negative 3.75 meters per second, okay? Because I did go backwards during that part, I should get a negative number. Okay, does that make sense to everybody? This was the most common mistake I saw walking around. Okay, was just seeing people use 500 instead of 200. Okay, total displacement over the whole trip, 0. Okay, why is it 0? Because my final position is 0 and my initial position is 0. Okay, final minus initial, 0 minus 0 is still 0. Okay, and the distance traveled in the first 200 seconds. Well, I already calculated that, but I can do it again. Okay, I go from 0 to 750. Okay, in that first 200 seconds. So total distance traveled, 750 meters. Okay, this is starting to make a bit of sense. Okay, like I said, these are really just word problems visualized. Okay, putting a graph up there, and it's a visualization of a word problem. Okay, I'm going to give you about a 5-minute break here or so, and then we're going to get back into some other stuff here. Okay, so take 5 minutes and